first grade introduction to energy. There are three forms of energy. Energy can come in the form of light. Energy can come in the form of sound. And energy can come in the form of heat. Energy. Energy moves in waves. Sound waves kind of look like this. Light waves move like this. And we have heat waves. They kind of look like this and they radiate out.
Vocabulary. Now we do. Making waves. Surf's up, dude. All these waves, I don't mean Miss America. Water sound like earthquake waves. Get it, bro? The wavelength is the space between peaks. The amplitude is the wave's height. Let's speak. When you do a cannonball and jump in the pool, you create waves. I'm sure you knew. But sound travels in waves too. So does light from a star or a bulb. It's true. Whether the waves from the sun or in the ocean, there's ways that we can describe its motion. Waves travel in patterns, their motion repeats. Let's measure some waves, the top's the peak. Wavelength is the distance between two peaks. So this wave has a wavelength of 10 feet. Even little waves have a wavelength feature. This wave has a wavelength of 20 millimeters. The amplitude is the wave's height, no problem. Measure amplitude from the middle to the bottom, or the middle to the top, you see. This wave has an amplitude of 6 feet. All these waves, I don't mean Miss America. Water sound like earthquake waves. Get it, bro? The wavelength is the space between peaks. The amplitude is the wave's height. Let's speak. All these waves, I don't mean Miss America. Water sound like earthquake waves. Get it, bro? The wavelength is the space between peaks. The amplitude is the wave's height. Let's speak. You might think waves make matter move, like this seagull would travel, if that were true, but that's not right. I mean, look at the dude. He bobs up and down, but he doesn't really move, and the same is true for the water beneath. Waves don't transfer matter, only energy. Same is true for the waves you can't see, but do different waves move at different speeds? Yeah, lightning strikes, see the flash, cause the light waves sped over real fast. Then you hear the thunder after. The sound waves are slow, but the light is faster. Earthquakes cause seismic waves, which move through the crust of the earth. I'm amazed that some waves travel so far, and for millions of years, like the light from a star. All these waves, I don't mean Miss America. Water sound like earthquake waves. Get it, bro? The wavelength is the space between peaks. The amplitude is the wave's height. Let's speak. All these waves, I don't mean Miss America. Water sound like earthquake waves. Get it, bro? The wavelength is the space between peaks. The amplitude is the wave's height. Let's speak.
All right. All energy forms move in waves. Light moves in straight lines in every direction away from the source. So here's light. It moves in straight lines away from the source. So our source is the light bulb. It moves away from the light in straight lines in all directions. Light is needed to see objects. When light hits an object, it reflects off the object. Different colors of light have different wavelengths. The object absorbs all light waves except the color that is seen. So when light goes out, it reflects all the lights, and so you're going to see that each of the colors has a different size of a wave. So this is red, and it looks, the wavelength is different than orange, which is different than yellow, which is different than green, and then different than blue. When the light, white light, remember, has all the colors of the rainbow in it. When white light comes, it has all of the colors of the rainbow. It comes in and it hits the object. All of the objects, all the other colors are absorbed. The only color that is reflected is the color that you see. So if you notice here, the green light comes in and bounces back up, and we see only green. Versus the yellow goes down and it's absorbed into the object, and we don't see the yellow, or the orange, or the red, or the blue, or the green, or the indigo.